It is common in design work to need to figure out areas of pipes, or diameters of pipes, or wall thicknesses of pipes, and this situation illustrates how helpful it is to make yourself a picture. Now, you might be better at visualizing than I am, but I find that I really need to just make a sketch of some circles on a piece of paper and label things in order to be sure that I'm getting it right. So let's think about these sizes. If you have some pipe and they tell you the outside radius and they tell you the wall thickness, well, you know the outside radius minus the wall thickness must give you the inside radius. All right, that seems reasonable. What about the diameter? With the diameter, remember that we have a wall thickness on each side. There's a wall thickness over here and there's another wall thickness over here. So for the diameter, the outside diameter minus one wall thickness minus another wall thickness, that will give us the inside diameter. This is why a picture is useful. Let's think of an example. Here's a pipe. This is a made-up size. Here's a pipe where the outside diameter is 10 inches and the inside diameter is 6 inches. And it's common to look those up in tables and you'll find those. How thick is the wall thickness? Be careful here. It's not just 10 minus 6. The outside diameter is 10 minus the inside diameter of 6 equals 4, but that 4 is 2 wall thicknesses worth of material, one over here and one over here. So the wall thickness of this pipe must be half that much. The wall thickness must be 2 inches on each side of the pipe, like this. 10-inch outside, 6-inch inside, 2-inch up here, another 2-inch down here. Let's try another one. In this one, the outside diameter is 8 inches. They tell us the wall thickness is 1 inch. What is the inside diameter? Be careful here. It's tempting to say, oh, going real fast, 8 minus 1 is 7, blah, blah, blah. No, it's not. Outside diameter is 8. There's a wall thickness of 1 up here and another wall thickness of 1 down here. So 8 minus 1 gives us 6. The inside diameter is 6 inches. Like this. 1 inch, 1 inch, 6 inside. Now, if you know the outside diameter and the inside diameter, and you need to find the area of the pipe, let's think. So we are familiar with the area of a circle being pi r squared. We could use that. So what is the radius of the outside diameter? If the diameter is 10, the radius must be 5. How about the inside diameter? If the diameter is 6, the radius must be 3. All right, there are our radii. And to find the area of a pipe, you take the area of the outside minus the area of the inside, and that gives you the net area of this donut shape that's remaining. And when someone says find the area of a pipe, what they mean is if you slice through this, let's say this is a steel pipe, you slice through this steel pipe with a saw, what is the area of that steel material that the saw cut through? That's the area we're talking about. So we're using pi r squared, and we found the radii. So pi r squared of the outside minus pi r squared of the inside will give us the net area of the pipe. Now, I think we've done this once before, but I'd like to do it again just because it's hard to hang on to sometimes, and we do want to hang on to it. So what if you're given the area of a circle and you need to find the radius of the circle? Let's say they tell you you found out the area of this circle needs to be 6 square inches. What is the radius that will give you that? All right, let's think about that. So we know that the formula for the area of a circle is pi r squared, and we know the area of this thing is 6, so 6 equals pi r squared. If we do the same thing to both sides, they are still equal, so we'll divide both sides by pi. The pi's cancel out on the right side, and we are left with 6 over pi equals r squared. Alrighty, 6 over pi equals r squared. We're trying to find r. How do we get from r squared to r? We take the square root of it. And as long as we do the same thing to both sides, they are still equal. So we will take the square root of 6 over pi and the square root of r squared. Square root of 6 over pi equals r. And we will, if we punch that into our calculator, we'll find out the number for r happens to be this number in this case. Just a caution, be careful with your calculator. Don't take the square root of 6 divided by pi. That will give you some other number. You want 6 divided by pi and then take the square root of that. So you could go 6 divided by pi, enter, square root, enter. Or you could punch square root, parenthesis, 6 divided by pi, close parenthesis. Either one of those will work. And I recommend you try it twice, 2 different ways if you can, maybe those 2 different ways I just suggested, and make sure you get the same answer both times. That can sometimes be a good check. The other thing that we've looked at before, but I just want to review it again, is that while we are commonly using area equals pi r squared, our book uses area equals pi d squared over 4. And let's think about why he does that. Because, as we remember from looking at pictures of circles, radius is half of diameter. So if area equals pi r squared is half of d squared. R squared is d over 2 squared, which is the same thing as d squared over 2 squared, which is the same thing as d squared over 4. So when you're figuring out area, you can use area equals pi r squared, or you can use area equals pi d squared over 4, whichever one is more convenient for the particular problem you're working on. Go ahead and use that.